Students, this question was asked in the year 2020 in IIT JEE Main from the chapter Units and Dimensions. Stopping potential depends upon Planck's constant h, current I, universal gravitational constant g, and speed of light c. Dimensions of stopping potential v is, we have to find out the dimensions of stopping potential v. Okay, student? It is given that v is directly proportional to h, v is directly proportional to I, V is directly proportional to universal gravitational constant G, V is directly proportional to C. So, stopping potential V is directly proportional to students' four physical quantity. So, we may write V is directly proportional to H to the power, say A, I to the power D, G to the power C, and C to the power D. Okay, students? Then, we may write that stopping potential V is equal to some constant. This is the constant of proportionality, students. Some constant into S to the power A, I to the power B, G to the power C, and C to the power D. Where H is the Planck's constant, I is the electric current, G is the universal gravitational constant, and C is velocity of light, students. But first of all, this question is asked from dimensional analysis, and from first thing we have to do is that find out the dimensional formula for each of these 5 physical quantities, students, so that we can find out the values of ABCD. So, students, what is the dimensional formula of V? V, students, V is potential difference, and this is equal to, we may multiply Q above and Q below. And what is QV, students? Suppose this is a point A, this is a point B, and suppose a charge Q is here, and the difference, potential difference between B and A is V volts. Then, if we have to take this charge Q from the lower potential point A to the higher potential point B through this potential difference V, we have to do a work which is given by students, charge into potential difference, or W is equal to QV. So, student, what is this QV? QV is nothing but W. So, V is equal to W by Q. And what is the dimensional formula for W, students? We know W work is force into distance, and force is MLT minus 2, and the distance is, or displacement is length. So, L, and the dimensional formula for work is ML2 T minus 2, which is the same as that of the energy. And this Q, what is electric current, student? I is equal to Q by T. Electric current is the time rate of flow of charge, or how much electric charge pass through a particular point in 1 second gives the electric current at that point. Okay, students? So, we may write Q is equal to I T here. So, what is IT? I is current and T is time, student. So, this becomes ML2 T minus 2, and dimensions of I, we know current is written as A, noting for ampere, and what is for T, student? That is capital T in square bracket. Okay, student? Then the dimensional formula for V becomes ML2 T minus 3 A to the power minus 1. Let us write it here. VH dimensions ML2 T minus 3 A to the power minus 1. Okay, students? Then the second physical quantity. What is the second physical quantity, students? That is Planck's constant H. Okay, student? This is Planck's constant H, and for H we know one formula, students. Can you tell me? Do you remember that? That is famous Max Planck's theory of quantization, which gives that the energy of a photon is equal to h nu, where nu is the frequency of the electromagnetic wave or radiation. Okay, student? This is the relationship between energy and frequency. So, from this equation, h is equal to E by nu, or dimensions of H is equal to dimensions of E upon dimensions of nu is MLT minus 2 upon what is the dimension of frequency, student? That is, you know, inverse of time period. So T minus 1 and this becomes MLT minus, sorry student, this is ML to T minus 2. Every form of energy has dimensions ML to T minus 2, which is same as work. So this becomes ML to T minus 1 is the dimensional formula for Planck's constant H. We write it here, ML to T minus 1. Okay students? Then what about the third physical quantity? That is current, electric current, and nothing to worry. Electric current is directly written as A ampere, A noting ampere in square bracket. I is, the dimensions of I is A. Okay student? And what is G? The formula for G can be obtained from Newton's universal law of gravitation. Universal law of gravitation. Okay student? You have studied Newton's universal law of gravitation. This tells that the force of attraction, or the attractive force of gravitation, that is gravitational force, A, is directly proportional to the product of the masses of the two bodies and inversely proportional to the square of the distance between them. So F is equal to G m1 m2 by r square, student, where G is the proportionality constant called the Newton's universal gravitational constant. So we may write G is equal to F square by m1 m2, and so dimensions of G will be dimensions of F square divided by dimensions of m1 and m2. This is, what is the dimensional formula for force, student? MLT minus 2, that of r square is L square, and this is M, and this is also M, because both the bodies have mass. Their dimensions can be written as capital M in square bracket. This M cancels out, and this becomes, student, m to the power minus 1 L 3T minus 2. Okay students? Then we write here that G has dimensions m minus 1 L 3 T to the power minus 2. Okay student? Then what about the next physical quantity? What is it? It is speed of light. And you know student, speed of light is also one type of speed, c. And what is speed, student? Speed is distance traversed by a body in unit time. It is distance by time. So the dimensional formula for speed is dimensions of distance upon dimensions of time, or L upon t, and so this becomes LT minus 1. We write it here, the formula for C, LT minus 1. Okay student? Now we will use the dimensional formula for these 5 physical quantities to write an equation which is given in this relationship. So what is V, student? So we will write like this: dimensions of V is equal to dimensions of K into dimensions of H to the power A, dimensions of I to the power B, dimensions of G to the power C, dimensions of C to the power D. Okay students? And what is the dimensions of K? That is M0, L0, T0, because this is a dimensionless constant, student. So what is the dimensions of V? We have written there M, L, L2, T minus 3, A minus 1. Okay student? This is equal to, what is H? H is ml2 t minus 1. We write here ml2 t minus 1 to the power A. What is current? I, that is A ampere to the power B. What is G, student? G is m minus 1 L3 t minus 2 to the power C. And what is the dimensional formula for C? Velocity of light, that is LT minus 1 to the power D. Okay student? Let us expand them. This will give us m to the power a into l to the power 2a into t to the power minus a to the power b into m to the power minus c, l to the power 3c, t to the power minus 2c into l to the power d into t to the power minus g. And let us write the exponents of m together. That will be